In this video, I will discuss some NEET PYQs from the topic motion in a plane. First, some basics. Work done by a force in making a displacement, say in this direction, small displacement ds, is given as f dot ds. F is a vector, displacement is a vector, and this is a small amount of work corresponding to the small displacement. So this is nothing but dot product of two vectors. So it's f into ds into cos theta, where theta is the angle between the two vectors, force and the displacement. This for a small displacement, but suppose you want to make a displacement, say from this point, say 1 to some point 2. So the total work done to go from 1 to 2 will be integral of dw from 1 to 2. So this is integral of f cos theta ds, integral from 1 to 2. This can write as f cos theta into ds, and f cos theta is a projection of the force along the direction of the displacement. So this is f component in the direction of displacement. If this force is constant and uniform, that is just a number, and also the angle theta is constant and uniform, then this thing can come out of the integral sign. So this thing will become f cos theta integral ds, which is the total displacement between 1 and 2, s12. So the next basic concept is vector addition using parallelogram law. All these basic ideas are used in the question. So two vectors, say A vector, and the second vector, say at an angle B. Parallelogram of addition of vectors says complete the parallelogram with these two as the sides of the parallelogram. So parallelogram, this side is parallel to this side. So I will draw a line parallel to this B vector, and from here I have to draw a line parallel to the A vector. So this diagonal is the sum of two vectors, A plus B. B vector is like this, so minus B vector will be in this direction. So this vector going from here to here, A minus B. That can be got from triangle of addition. One vector, second vector, head and tail are touching. So this vector is minus B and then plus A. So that can be as A minus B. So in a parallelogram formed by the vectors A and B, one diagonal is the sum of the two vectors A plus B, and the other diagonal is the difference of the two vectors A minus B. So here the one diagonal, when we call this D1, and the second diagonal D2. So D1 length is greater than D2. Is it possible for the two diagonals to be equal? D1 equal to D2. Is this possible? So for that I have to press a parallelogram like this. So if it becomes like this, A vector and B vector with 90 degrees, So in the case of rectangle, both the diagonals are of same length. This is a plus b by parallelogram addition, and the other diagonal is a minus b. So in the case of two vectors a and b making 90 degrees, the parallelogram will become a rectangle. So in that case, both the diagonals are of same length. Next idea, position vector of a point. See, from a origin, this vector, its r, is given as x I cap plus y j cap plus z k cap. As the particle is moving, say, to this point at a later time, so all this x, y, and z can be function of time in general. Position vector is also a function of time. Initially, the position vector of this one, at a later time, it is this one. So to get the velocity of this particle, it's dr by dt, velocity vector, and acceleration is how fast the velocity is changed. So it's dv by dt. So if you put v as dr by dt, it will become second derivative of r with respect to time. So this, you have to differentiate this thing twice to get the acceleration. So you have to differentiation term by term, so it will become d square x by dt square I cap plus second derivative of y with respect to time j cap and then z, second derivative. So given position vector, you can find acceleration by taking the second derivative of the position vector. Or you can take the, to put in other words, to get the x component of acceleration, take the derivative of the x component of the displacement twice. Y component of acceleration, take the derivative of y component of displacement twice. Similarly, z component. Next basic concept is there is an acceleration which is constant and uniform in some direction, and there is velocity, initial velocity of the particle u in some direction which is not same as a. It's making an angle theta. So in this case, the motion will be in a plane formed by the two vectors u and e. Any two vectors will form a plane. Suppose this a vector is like this, but u vector is out of the plane of the board, then the motion will be in this plane. So I can assume the two vectors to be in the plane of this board without any loss of generality. So for this thing, you have to split the velocity into two components. One along the acceleration direction, that's u cos theta, and one in the vertical other direction, perpendicular direction, u sin theta. So this u cos theta will get accelerated, will keep on increasing, and u sin theta will be a constant velocity motion. One example of this type of motion is projectile motion, where there is, say, mass is here, m, Earth is pulling it down, so acceleration is downwards, which is g, and it's projected to the initial velocity u. Okay, suppose it's u makes an angle theta with the, or let's say alpha, with the horizontal. So u cos alpha is like this, u sin alpha is like this. U cos alpha, there is no force in the horizontal direction because acceleration is vertical. So there will be uniform velocity motion in this horizontal direction, u cos alpha into time. So if you take this as x-axis, x of t will vary like this. But this vertical motion u sine alpha, since Earth is pulling it down, it's opposing the motion, so it'll keep on decreasing and it'll turn back. So uy is somewhat like this, it'll keep on decreasing. Finally, the vertical velocity will become 0 here, and then it'll turn back. It's going upwards. This is a projectile motion, and we know this path is a parabola. So this idea we can borrow for this situation where acceleration is constant and uniform, same as this g here, and u has got a component along the acceleration and vertical perpendicular component. So this perpendicular component will not have any acceleration, will be constant. Here it is horizontal component is uniform, no acceleration direction because acceleration is vertical here. So the path of this thing will be a parabola. Next idea is given force, if force acting on a body is given, see force could be a variable force, if it is given, from that can I find acceleration? Acceleration can be found out using this relation force equal to mass into acceleration. This is Newton's second law. So force is known, if the mass is known, then acceleration is known. So acceleration is force divided by mass. So once I know acceleration, from that I can find the velocity, because acceleration is rate of change of velocity. So that means a dt is dv. So if integrating both the sides, I'll get velocity as integral of the acceleration with respect to time. So given force, I can find the velocity. One more basic concept is dot product of two vectors. Given two vectors, C A and B, the dot product is defined as A dot B equal to A into B, magnitude of the two vectors, into cos of the angle between them. So if you want to find the angle between the two vectors, I can get cos theta from here as A dot B by magnitude of the two vectors product. So this dot product is known and the magnitude of the vectors is known, then theta, cos theta is known. So from this I can find the angle theta. One particular case, say theta is 90 degrees. That means cos theta is cos 90, which is 0. Sin 90 is 1, cos 90 is 0. So that means A dot B is 0 when theta is 90 degrees. Theta 90 degrees means A and B are perpendicular, because theta is angle between A and B. So for perpendicular vectors, the dot product is 0. So with these basic ideas, we can solve these NEET PYQs. Timestamps are given in the description box. You can watch parts of video if you are running short of time. I'll discuss some 6 questions. This is the first one. Your body is constrained to move in y direction, is subjected to a force F equal to minus 2 icap, 15 jcap, 6 kcap Newton. What is the work done by this force in moving the body through a distance of 10 meters along the y-axis? Work done is F dot ds for a small displacement. It is F dot ds. This is F into ds into cos theta. So this can be interpreted as f cos theta into ds. That is component of f along the displacement direction. Here the force is just a number, it's constant and uniform, and the angle theta between the displacement, which is along the y-axis, and the force is a constant vector. So displacement along the y-axis, jcap, and force is in some direction. But this angle is constant. So I'm going to change. So to get the total work done, so this f component will come out, and you have to take the total displacement. So f component along the direction of displacement, the body is moving along the y-axis. So force component along the y direction is 15. And the displacement along the y direction is 10. So 150 joules. So option C is the answer. Actually, one small information is missing in this question. The force in the positive y direction, and the displacement here, it's along the y-axis, but they have to mention it's the positive y-axis. If it's the positive y-axis, then it will be plus 150. If the displacement along the negative y-axis, along the direction of negative y-axis, then the answer will be minus 150. So work done is F dot S. Since the force is constant and uniform, just a number, so it will be F into the total displacement. You have taken the displacement in the positive y direction, which is not mentioned in the question, but it's being assumed, so it's plus 150. This is the next question. If magnitude of sum of two vectors is equal to the magnitude of difference of the two vectors, the angle between the two vectors is. So sum of the, according to parallelogram law of addition, two vectors like this, A and B. Sum of the vectors is this diagonal, or to complete the parallelogram. So this is the sum of the two vectors, and this one is the difference. So the other diagonal, A minus B. Since these two sum and difference are equal, that means this parallelogram is a rectangle. Only in a rectangle, both the diagonals are of equal length. So that means the angle between the two vectors is 90 degrees. Another way of getting the same answer is sum of the two vectors is A plus B. So its magnitude is same as the difference of the two vectors magnitude. I'll use one more basic idea that magnitude of a vector can be got as dot product of the two vectors and take the square root. Because dot product is A into B into cos theta, here A and B are same, will be A square into cos theta, and between this one, it's 0 degrees, and this is 1, so this is nothing but A. So to get the magnitude of the vector, I can take the dot product and take the square root. So this means the dot product of A plus B with itself equal to A minus B dotted with A minus B. Take the square root, but we can square both the sides, so the square root can disappear. If this is equal, means square root is also equal, and magnitude square is nothing but dot product. So this we can simplify. So this is the A dot A plus B dot B. We just have to multiply like two algebraic factors, and it will become 2 times A dot B. So this will become A dot A plus B dot B, and then minus 2 times A dot B. So this will cancel A dot A, this one. So it will become 4 times A dot B is 0. That means A dot B is 0. Dot product of two vectors 0 means cos of the angle between them, that is 0. That means theta is 90 degrees. Two vectors dot product is 0 means they are perpendicular. So answer is B. So this is what is done here. Squaring both the sides. We'll take a quick look. Let's go to the next question. The x and y coordinates of a particle at any time are x 5t minus 2t square, y is 10t respectively, where x and y are in meters and t in seconds. The acceleration of the particle at t equal to 2 seconds is. Simple question. So x and y is given. Position out of the particle is xi cap plus y j cap. Z is actually constant or 0. So only x and y are varying with time. So to get the acceleration, you have to differentiate this thing twice. With respect to time. Acceleration is dv by dt and v is dr by dt. So acceleration is second derivative of the position vector, which is nothing but, so you can do this thing components. So it will be d square x by dt square I cap, second derivative of y with respect to time, j cap. So x component, if you differentiate this thing twice, you will get 5t and then 0. First time if you differentiate twice, you become 0. 5t differentiate once, you become 5. 5 if you differentiate again, with respect to time, become 0. This thing will become minus 4t and then 4. So this into I cap. Y if you differentiate twice, first time differentiate will become 10, second time will become 0. 0 j cap. So acceleration is minus 4 I cap and SI units, because x and y are in meters, t is in second, SI unit, the acceleration is meter per second square. Direction is I cap. So this is what is done here. X is given, y is given. Velocity, you have to take the first derivative. It will become 5 minus 4t. Acceleration, second derivative. So 5 will go minus 4. Y velocity, differentiate this thing once, you'll get 10. Acceleration, differentiate this thing, it will become 0. Let's move to the next question. A particle moves in a plane with constant acceleration in a direction different from the initial velocity. The path of the particle is. This already explained the concept. Acceleration is constant. So it will be in some direction. And there is an initial velocity which is not along A, but in a direction, making an angle, some angle with the. So this is A. And this angle, say it's theta. So U will have two components, U cos theta along the direction of acceleration, U sin theta in the perpendicular direction. This U sin theta will not change. It will be remain constant because acceleration is only the this direction. So perpendicular direction, there is no force to change this u sine theta. So in this direction will be a uniform velocity of motion of value u sine theta. In this direction, the velocity will keep on increasing. But the path will be a parabola. This we can understand from the projectile motion, where the mass is moving under the influence of gravity thrown from the Earth's surface. So correct option is option B. This is the next question. A body of 3 kg moves in xy plane under the action of force given by x component 6t square, y component 4t. Assuming the body is at rest at time t equal to 0, the velocity of the body at t equal to 3 seconds is. We'll pause and run this question. Force is given. So force is given means acceleration is known by Newton's second law. Force is 6t square I cap plus 4t j cap. From this, I can get the acceleration as function of time. Force by mass. Mass is 3. So this divided by 3. So become 2t square I cap and then 4 by 3 t j cap. So velocity from the acceleration, the relation between acceleration and velocity is acceleration is defined as rate of change of velocity d by dt. So you have to integrate both the sides. So that will give a dt integral as velocity. A dt integrate both sides, you'll get this one. So acceleration, if you integrate, so there are 2 times I go. One is t equal to 0, one is t equal to 3 seconds, and at t equal to 0, velocity is 0. So you have to integrate between the limits, between the time limits 0 seconds and t equal to 3 seconds. This here t is 0 to 3. This is nothing but velocity at 3 seconds minus velocity at 0 seconds, which is 0. At rest at equal to 0. So acceleration, you have to integrate this thing term by term. So it will become 2 t cube by 3 I cap, and you have to put the limits here 0 and 3. And the second term is 4 by 3 t square by 2. You have to put the limits and then j cap. So 2 by 3 t cube, this velocity at 3 seconds. 2 by 3, upper limit is t cube is 3 cube, minus the lower limit is 0. So this into I cap, and then the j cap component is 2 by 3 t square j cap. So it will be 2 into 3 square I cap, and then j cap will be 2 into 3, 6. So this is 18 and then 6. Option B. Option B is the correct answer. So force is given. So from this acceleration can be get as force by mass. Mass is 3 kg. So it will be 2t x component, and y component of the force acceleration is this force divided by the mass, which is 4 by 3. And it is 2t. And there is a mistake here. Force is t square. So t square. Acceleration is this one, t square. Here it is correct. So if you integrate, it will become t cube by 3. From here it's correct. So if you do the integration, you get 18. And after that, same for the y component. 4 by 3t. So it will become t square by 2 after integrating. So put the time value as 3 seconds, you'll get this thing as 6. This is the next question. Vectors E cos omega t I cap plus sin omega t j cap, and B A cos omega t by 2 I cap plus sin omega t by 2 j cap are functions of time. Then the value of t, at which they are orthogonal to each other. Yes. Orthogonal means they are perpendicular to each other. So when they are perpendicular, dot product will be 0. Because dot product perpendicular faces A into B into cos 90, which will be 0. So you have to find A dot B, and then you have to find when this thing becomes 0. So A dot B means I component dot cos omega t into cos omega t by 2 plus sin omega t into sin omega t by 2. So this thing should be 0. So we have this cos A plus B formula and cos A minus B formula. Cos A minus B is cos plus sin. So this is nothing but cos omega t minus omega t by 2, which should be equal to 0. That means cos omega t by 2 equal to 0. That means the angle should be 90 degrees. So omega t by 2 should be 90 degrees, and radius should be pi by 2. So from this, time should be equal to 2 will cancel, pi by omega. B is the correct answer. That's what's being done here. Two vectors A and B are given. For the two vectors to be orthogonal, the dot product is 0, because A dot B is A and B into cos of angle between them. So cos 90 degrees is 0. So A dot B will be 0. So A dot B, if you do this, you'll get this one, I component and then G component. So this is cos A minus B formula. So cos of A minus B, which is this one. And for this to be 0, cos 90 is 0, or pi by 2, cos pi by 2 radians is 0. From this should be pi by 2. That means time is pi by omega. You can ask your doubts in the comment section.